Me and my jowa. Wah! Uuwi na siya. Uuwi na siya. Wah!
Ay, huwag mo rin ko'y jowa.
One day when the sky is falling.
Hello guys, good morning and welcome back to our class in ESci132, your mechanics of deformable bodies. And now we are on our second to the last lesson for this year 2020. And I hope that after all our topics that we have dealt with on the previous weeks, you still can remember everything, especially on the concepts, especially on the things that I've taught you. On the previous week, we have started on our fourth module, and our fourth module was all about torsion. And first, we generated an equation about torsion, about the torsion formula, and then we learned that the maximum shear stress or the shear stresses of your shaft that is subjected to torsion can be solved by Tc over J, which your T is your torque applied, your C or your rho is for your C, that is the outermost part of your shaft, and your rho is a differential element or an element that is from the center of your shaft. And your J is your polar moment of inertia, that we all know that your polar moment of inertia of a hollow and on a solid tube is different. Okay? So now let's proceed to our next topic. Our next topic is all about power transmission. This is very important because all our shafts usually are used for machines, because in order for our engines to transmit that power to the machine, it requires a shaft so that it can transmit the power by rotation to the parts of that machine. Okay? For our main goal for this lesson, we have to first generate an equation that will relate your power and the torque that is applied. And later, also we have to aim to solve problems by using these equations that we have generated. Okay? And as you can recall, how can you determine power? Diba, we all know that your power is the rate of work. And you know that your translational work, ang pasabutan ng translation is from one position to another position, is just equal to the force times your distance. And when you say this one is power, so therefore, this is per second. But how about for these shafts that are rotating? What is the power of that one? Diba? Again, sa atong work is force times distance. Kung translation siya from one position to another position. But how about sa kanang atong rotation? So, take note, para makuha nimo ang work sa kanang nag-rotate nga shaft, ang imong button, torque multiplied by the angle of rotation. Take note that your torque should be in Newton meter. Okay? So, work naman yung iyong unit. Unsa man na yung unit aning atong angle, this should be in radians. Okay? So therefore, if at an instantaneous time of dt, nakay gi-apply nga torque sa usa ka shaft, and kanang shaft ni-rotate siya at an angle of d theta, therefore, your angular velocity will be equal to d theta over dt. Okay, di ba? Kung mag-ingon tag velocity, murag distance over time. Pero kung mag-ingon kag angular velocity, which is this one is omega, that one will be equal to the rate of the angular rotation of your shaft. So therefore, ang imong power is just equal to the torque that is applied multiplied by the angular velocity. So di ba ang atong power has a unit of Newton meter per second. Diba? So therefore, this angular velocity, this omega right here is in radians per second. And your torque is in Newton meter. So this one is equal to Newton meter per second because radian is unitless. Right? So, nga na lang. Take note that your omega should always be in radians per second. This is not in degrees. Take note with that always. And now, usually, ang kanang atong rotation sa atong shaft, wala na siya gi-express as radians per second. Di ba? Kay nakahibaw man ta nga kana siya na siya gitawag nga number of rotations per second or number of cycles per second. Ang kana cycle usa ka revolution na ang usa ka cycle. Mana tong gitawag nga frequency. Okay? And your frequency has a symbol of F. And your frequency has a unit of
It really hurts ang magmahal ng ganito kung sino pang
So ang atong frequency has a unit of hertz. Okay? And this one is expressed in number of revolutions per second. And now, since one revolution, pila man ka radians ang one revolution, di ba one revolution is equal to 2 pi radian. Di ba? Therefore, your omega right here is equal to, di ba ang atong omega is your angular velocity per time. So kung ang imong revolution is 2 pi rad and this is equal to F, then you can express your angular velocity as 2 pi multiplied by the frequency. So this is the number of cycles per second, and this one is for you to convert your revolutions into radians. Okay? So therefore, to simplify this one further, you can get that your power is equal to 2 pi frequency times torque. Okay? So I think you're very familiar of this equation because perhaps this one is already shown in your power, or I don't know. But mo ni atong general equation. And usually ihatag na sa anang atong engines ang power and then ang number of revolutions, number of cycles per second. So therefore, by that you can solve for T, and when you're going to solve for T, when you identified your material and your material has an allowable shear stress of that one, and by using this equation, then you can solve for this C. And that C is now your radius sa imong shaft. And by knowing these values, you can now design your shaft. So mo na, as engineers, we should be able to design sa mga dimensions sa atong shaft. So, for you to be able to know for the radius of your shaft, you should be able to first know the power requirement of your machine and the number of revolutions ng imong machine per unit of time, and also the maximum allowable shear stress of your member. And you can solve for C, including also the factor of safety, of course, because you need that one. Kay kung imo ra na iabutan nga threshold, then probably it will still break because wala man imong gibutang allowance. Okay? So now, let's have a problem. So in our first problem, we have this steel shaft AB. And kani atong steel shaft, i-connect ni siya dito sa atong A, sa atong motor. Sa atong motor. And then, tungaan ang atong AB na igibutang nga pulley. And then, diha naka-connect ang atong belt. Then, your shaft AB daw rotates at 175 revolutions per minute. Okay? And the allowable shear stress of your steel shaft is 14.5 KSI, kilopounds per square inch. The problem is, we have to determine the required diameter of the steel shaft AB to the nearest 1/8 inch. Okay, so how can we solve this problem? Diba? Ang atong given ng mga formula is P is equal to 2 pi ft. And then we also know that kadong atong tau max is equal to TC over J. This is what we are looking for, your C. And if we're going to multiply it by 2, then we can get the diameter. Then, your polar moment of inertia, wala pa ta kay bao ana. Because this also requires your diameter. So we have to still put it as blank there. How about the torque? Can we solve for the torque? We can solve for the torque by having our power. Our power is 5 horsepower. The problem is, ang atong horsepower, dili siya ma-apply ng equation. We have to change the unit of this one. Unsa may maayo nga unit nato, di ba? Ang unit sa force is a pound-foot per second. Mao ning atong ganahan nga power. Dili kani. So how are we going to convert that one into that one? We have a conversion. 1 horsepower daw is equal to 550 foot-pound per second. Okay? So therefore, 550 times 5, of course. Okay. And we are given your F. Your T is not given. And when we get our T, we can solve for C and J. Okay? Sige, let's do this. Una sa taaning equation. First, let us get the power. The power in foot-pound per second. So, 5 horsepower multiplied by 1 horsepower is equal to 550 foot-pound per second is equal to, cancel, so 550 times 5. That is 2,750 foot-pound per second. Okay, so that is our power. And we are given that our frequency is 175 revolutions per minute. But our unit in power is in seconds, so therefore we should also convert the unit of our minutes into seconds sa atong frequency. So therefore, that is frequency is equal to 175 revolutions per minute. Now, to convert this one, we should change this one into seconds. So that is 1 minute 60 seconds. Equals to, cancel. So that is 2.9167 revolutions per second. Okay? So now, let's proceed. So therefore, your torque DI is equal to 2,750 foot-pound per second divided by 2 pi times your 2.9167 revolutions per second. Cancel, and this one can be converted na. So, let's see. So, our torque right here is 150.1 foot-pound. Okay? So, we already solved for the torque, and let's now solve for the diameter. Okay? Sige. So, unsa man nato. So, take note, ang ato una kuhaan kay ang radius. Kay di ba ang C is ang gikan sa center pa dong sa outermost. So, radius lang sa nato kuhaan. And then later, ato i-multiply by 2 to get the diameter. Sige. So, your allowable maximum shear stress is given as 14.5 kilopounds per square inch. Okay? Take note. And that is equal to the torque, which is 150.1 foot-pound. Pero ang gihatag diri is kilopounds per square inch. So we have to convert pounds into kilopounds and foot into inch. Okay, so let's do that first. 150.1 foot-pound times 1 foot 12 inches times 1 kilopound is equal to 1,000 pounds. That is equal to 1.8012 foot. Inch, pound, keep inch, whatever. Okay, so 1.8012 keep inch. C, we don't know, over J. So, gani polar moment of inertia sa atong solid shaft, pi over 2 times C to the 4. So we have two unknown C's. So therefore, by using your calculator, perhaps you can solve for C, which is equal to, dugay ni mag-solve, feel na ako, okay, na to the 4th. Math error, math error. 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 Math error. Math error. Math error. 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 There! Your answer for C is 0.429213. And that is in inches because inch ato tanan na dito. Diba? This one is in radius. Okay, pastilan. And to get the diameter, we have to multiply that one into 2. So by multiplying that one into 2, we have 0.858 inches. And to get the closest 1/8 inch, then we have here, your closest 1/8 inch is 0.875 inch. Or that is 7/8 inch. And this is your final answer. So this one is applied to all kinds of problems. Balik-balik lang ni. Once, if you already know how to play with the torque, with the power, and with the frequency, then you can just go through all of those problems that you have in the reference that we use. So understood? So, ingani ka importante. Then you will be able to design kaning mga shafts by given the power, the frequency, and the torque, and the maximum shear stress or the allowable shear stress. So, yun lang. So, as a summary for this lesson, for this topic, we have created an equation that will relate your power, your frequency, and your torque. And we also solve for the diameter of a shaft given with these values sa imong power, sa imong frequency, and for your allowable shear stress. So I hope that you can apply this one when solving problems and later on when you are going to design machines, especially those shafts. So if you don't have any questions, then we will see each other again on our next lesson, on our next and last lesson for this year, and see you again later. Peace.